Now we are seeing problem from the topic simple stresses and strains. Let us see the problem. A MS bar has a diameter 10 mm and 350 mm long. A tensile load of 15 kilonewtons is applied longitudinally. Calculate the extension of the bar, change in diameter and change in volume. Assume E, that is Young's modulus, is equals to 2 into 10 to the power of 5 Newton per mm square, and Poisson's ratio is 0.25. So here a MS bar rod is given of 10 mm diameter. On this bar 15 kilonewtons tensile load is applied like this, and the length of the bar is given 350 mm. So for this case we have to find out change in length, that is extension of the bar, and change in diameter and change in volume we have to find out. So let us see the given data. Diameter of the bar D is given as 10 mm. Length of the bar L is given 350 mm. Load applied is given P is equals to 15 kilonewtons, or 15 into 10 to the power of 3 newtons. And also Young's modulus is given 2 into 10 to the power of 5 Newton per mm square. Poisson's ratio 1 by m 0.25. These are given, and we have to find out change in length, that is extension delta L, and change in diameter delta D, and change in volume delta V we have to find out here. So in the first step, to find out extension delta L, so to find out delta L, we will use the formula PL by AE. So how we can write this formula? Let us see here. So from the basic formulas, Young's modulus is equals to stress by strain, or strain is equals to stress by Young's modulus. Strain we can write delta L by L, and that is stress by Young's modulus. And if you write here delta L is equals to stress by Young's modulus into length, and we can write stress as P by A, load by area. And if you rearrange the terms, we can write delta L formula as PL by AE. So from that way we can write delta L formula as PL by AE. And here P given, L is given, and E also given. So we require area. So if you write area, so it's a round circular bar, cross sectional area is pi by 4 d square. D is given 10, and if you substitute here area, we are getting as 78.54 mm square. So when you substitute those values in this formula, P is 15 into 10 to the power of 3 newtons, L is 350 mm, A we got 78.54 mm square, and E Young's modulus 2 into 10 to the power of 5 Newton per mm square. We are getting extension or change in length of bar as 0.3342 mm. So in the next step, we have to find out change in diameter delta D. So for that, let us see. We know Poisson's ratio is equals to lateral strain by longitudinal strain. So here bar is given, circular bar, and this tensile load is applied like this, means along the lengthwise tensile load is applied. So in this case, this will become, or the strain in lengthwise will become primary strain or longitudinal strain, and strain in the diameter direction will become secondary strain or lateral strain. So we can write lateral strain as delta D by D, and longitudinal strain as delta L by L, and Poisson's ratio 1 by m here. And here Poisson's ratio value is given 0.25, and if you rearrange these terms, delta D by D into L by delta L, and here D is given 10 mm, L is 350, and delta L we got in the previous step 0.3342. So when you write, and if you write the for delta D like this, we can rearrange, and when you simplify that, we are getting delta D, that is change in diameter, as 0.00238 mm. So in the next step, we require change in volume. So in the case of circular bar subjected to tensile load like this, the change in volume or the volumetric strain is given by the formula sigma by E into 1 minus 2 by m, where sigma is the stress in the bar, E is Young's modulus, and 1 by m is Poisson's ratio. And here E is known and 1 by m is known, and stress we can calculate by simple formula load by area. Load we know 15 into 10 to the power of 3 newtons. Area we got in the first step 78.54 mm square. So the stress in the bar we are getting as 190.98 Newton per mm square. So when you substitute these values in this formula, that is stress value, and Young's modulus value, and it is 2 by m is 2 into 1 by m, and 1 by m value is Poisson's ratio, that is 0.25 given. So when you substitute those values and when you simplify, we are getting delta V by V, that is volumetric strain, as 0.00048, or if you require change in volume, delta V or dV, it is 0.00048 into V. So where V is nothing but volume of this bar, that we can write area into length. Area we calculated in the first step, that is 78.54 mm square, and L is given 350 mm. So when you substitute those values and when you simplify, we are getting change in volume delta V or dV as 13.194 mm cube. So for more videos, please subscribe and activate bell symbol. Please like it, share it with your friends, and don't forget to subscribe. Thanks for watching.